In this lesson, students will define isosceles and an equilateral triangle and then solve problems involving those triangles. Okay, so the definition of an isosceles triangle, the official definition, is a triangle that has at least two congruent sides. So if I were to draw an isosceles triangle, typically, here's your triangle. We have two sides that are equal, so I have the tick marks there. And we have some terminology here. So the angle at the top, that's called the vertex angle. And the two congruent sides, those are the legs. So we have a leg here, we have a leg here. The non-congruent side, if you have a non-congruent side, that's called the base. And so we also have base angles, which would be a base angle is there, and a base angle is in the other corner. Okay. In an isosceles triangle, we'll write the theorem in just a minute, but the base angles are also going to be congruent, so I would mark them like that. So we have what's called the base angles theorem from that isosceles triangle. And it basically says if two sides of a triangle are congruent, the angles opposite them are congruent, which is basically what an isosceles triangle is. So again, if I were to draw that, if I have a triangle and I have two sides congruent, then it's accepted to be true. I mean, we're going to just use the theorem as it is, that the sides opposite those angles are also congruent. So base angles of an isosceles triangle are congruent. The converse is also true. So the converse says this: if two angles in a triangle are congruent, the sides opposite them are congruent. So this is how, for the first theorem, if we were doing a proof, which we will do later in the unit, this is how I can start. If I start with an isosceles triangle, I can say the two sides are congruent. And from there, I can say the two angles are congruent, because an isosceles triangle is defined as having at least two congruent sides. So we don't define it with the angles, we define it with the sides, if you want to be picky about it. And then down here, this is a way to prove a triangle is isosceles. If you have two angles congruent, then you can say the sides opposite them are congruent. And then you can say the triangle is isosceles because it has at least two congruent sides. Okay, the next theorem we have is called the isosceles bisector theorem. And it says, if a line bisects the vertex angle in an isosceles triangle, then it is a perpendicular bisector of the base. So let's draw that. So here's my isosceles triangle. If I we can label this A, B, C. If I draw in line segment BD, if it bisects the vertex angle, then it's perpendicular to the base, and it also bisects the base. So you could write it like this: if you're given that BD bisects angle ABC, then BD is perpendicular to AC, and AD is congruent to DC. So those are things you can use in a proof when we get there. Because if you're given that BD bisects ABC and you know it's an isosceles triangle, then you can assume these things based on that, okay? Based on the isosceles bisector theorem. The converse is also true. If BD is a perpendicular bisector to the base, then it also bisects the vertex angles in an isosceles triangle. Not every triangle, just an isosceles triangle. So now we're just going to do a few numerical examples. We're going to focus on just solving for unknown angles And then later on in the unit, we'll start incorporating some of these theorems into proofs. All right, so here we have an isosceles triangle based on its markings. I have one side is 32. This is perpendicular down here. So if it's going to be perpendicular, that means it's going to be the perpendicular bisector, and it's going to bisect this angle up here. Find the measure of angle A. Well, first I have to find the full vertex angle. And since I have angle BCBD is 32, I know that the measure of angle ABD is 32. Because I have the perpendicular bisector, therefore it bisects the vertex angle. Okay, so I have, this is 32. So down here, I know that these two angles are congruent. And if this is going to be x, then this is going to be x. And I have x plus this whole angle up at the top is 64. That's going to be equal to 180. So 2x plus 64 is equal to 180. Subtract 64, you get 2x is equal to 116, and then x is equal to 58. So the measure of angle A is 58. You could have also just used the right angle and said 32 plus x is equal to 90. That also would have worked. Okay, for the next example, it says a base angle of an isosceles triangle is 50 degrees, and we want to know the vertex angle. So this is a classic isosceles triangle problem. Here's my isosceles triangle. If a base angle is 50, that means the other base angle is 50, and we're trying to find the vertex angle. So again, you add them up. 100 is equal to 180, and in this case, x is going to be 80. So whenever you have an isosceles triangle problem, all you need to know is one of the angles, and you can find the other two. Whether you're given the vertex angle, if you're given the vertex angle, then both of these would be x. Or if you're given a base angle, you have the other base angle because they're the same, and then the vertex is x. Okay, and here we're given, we know it's an isosceles triangle because the two sides are equal, and each of these are 40 degrees, so this line here bisects the vertex angle, and I've got to put the letters on here so we understand what we're asking for. This is y, this is x, this is k, this is z. So first we want to know, what is the measure of y, k, z? Well, because it's isosceles and this line yk bisects the vertex angle, we know that this angle has to be 90 degrees because that yk is the perpendicular bisector. Okay, and then we got to find the measure of angle z. We can either use the entire isosceles triangle or we can just use this side because I know this is 90 and that's 40, and these two have to add up to 90 because the whole thing adds up to 180. So if I did, if this is x, and I said 40 plus x plus 90 is 180. You don't even have to show that part if you know in a right triangle that the other two angles have to add up to 90. X is going to be 50 degrees. Finally, we're just going to define what an equilateral triangle is. An equilateral triangle is where all the sides are congruent. So an equilateral triangle is considered an isosceles triangle. It's a special case where all three sides are congruent. Therefore, all three angles are congruent. And if you're trying to find the angle measure, the sum of the angles is 180, so you're dividing by 3, and in an equilateral triangle, each angle is 60 degrees. And in class, we're going to be constructing an equilateral triangle and then also working some of these problems.